Okay, so we did a mass on a string, and we're talking about centripetal force. And centripetal force, we said, is not a real force. It is the result of a bunch of other forces. And so what we're going to consider in this lecture is a car rounding a level turn. Car rounding a level turn. Okay, so here's my side view or behind view. Road. Car. Force gravity, force normal, and then we're going to have force friction, force friction, and that force friction is going to be our force accelerator. That's going to be our force centripetal. So what's going to cause the car to be able to go around the turn is going to be the force centripetal. So top-down view. Here's my car, and it's moving in this way, so there's going to be a force centripetal, and that force centripetal is going to be caused by friction. Well, we know that our force due to friction, we know that we have this equation, mu equals force friction divided by force normal. Okay, so that means that our force friction is going to be mu force normal, and because of a level road, our force gravity is going to equal our force normal, just because we're on a level surface. So I'm going to say force friction is going to be mu force gravity. Okay, so let's come up with some plausible numbers here. We want a car with a mass of 1,500 kilograms going 40 miles per hour around a turn, radius of, let's say, 200 meters. Okay, so we need to come up with a few conversions. 40 divided by 2.24. I should have said it, call it 18 meters per second. Okay. So what we're going to have is we're going to have a force gravity on that object is going to be 1,500 times 9.81. It's going to be 1.47 times 10 to the 4th newtons. And we're going to have force centripetal is going to be mv squared over r. So it is going to be 1,500 kilograms times 18 meters per second, and I gotta remember to square it, divided by my radius, which is 200 meters. And so my force centripetal is going to be 1500 times 18 squared divided by 200. It's going to be 2.4 times 10 to the third. I'm going to leave the units the same. 0.24 times 10 to the fourth newtons. And now that is going to be how much friction needs to be between the tires between the tires and the road. We're going to need this much friction, because if we don't have that much friction, we can't get this centripetal acceleration, and Newton's first law is going to take over, and we're just going to track straight down the road and hit a tree or something. We're going to go in a straight direction, and the road turns, and that's not a good deal. Okay, so if I back up, I said we need force gravity is 1.47 times 10 to the fourth newtons, and we're also going to say that that's force normal because the road is level. And we said that our force centripetal was 0.24 times 10 to the fourth newtons, which is also equal to force friction, because that's what's causing us to turn, is the friction between the tires and the road. So I'm going to say that mu is force friction over force normal. So I'm going to get 0.24 times 10 to the fourth newtons over 1.47 times 10 to the fourth newtons, and so I'm going to end up with 0.024. I'm going to 0.24 divided by 1.47 is 0.16, and that is very reasonable. In fact, what's normal is mu of about 0.8 for good tires on good, dry pavement. So let's see if we can back this up real quick. That's going to say my force friction is going to be 0.8 times 1.47 times 10 to the fourth newtons. So that's going to be 1.2 times 10 to the fourth newtons. That's going to be the maximum force centripetal that I can get. So I can get 1.2 times 10 to the fourth newtons. Fc equals mv squared over r. So I'm going to end up with my v is going to be the square root of rfc divided by m. So I'm going to get square root of 200 meters was the radius of our turn. Fc is 1.2 times 10 to the fourth newtons. My mass is going to be 1500 kilograms. And I get square root of 200 times 1.2 second EE4 divided by 1500, and I get 40 meters per second. So I could have gone around at 40 meters per second as opposed to 18 meters per second.